Welcome you all. Now we are going to discuss about shift registers. What is shift register? The shift register is another type of sequential circuit that can be used for storage or the transfer of binary data. So it is a functional unit which acts as an interface to allow the data to be transferred from a serial to parallel or from parallel to serial systems. So either the input is a serial input and the output is a serial data output, and either the input is a serial data input and the output is a parallel. If the input is a parallel in and the output is a parallel output, next the parallel input and the serial output. A shift register basically consists of several single bit. So the D flip flop data transfer the one of the each data bit, either a logic 0 or logic 1, connected together in a serial type daisy chain arrangement, so that the output from one data latch becomes the input of the next latch and so on. The shift register are used for data storage or for the movement of data, and therefore commonly used inside the calculators or computers to store the data such as two binary numbers before they are added together, or to convert the data from either a serial to parallel or parallel to serial format. And here the individual data latches that may make up a single shift register are driven by the common clock signal, making them synchronous devices. Next, the types of shift register. The shift registers are classified into 4 types. Serial in, serial out shift register, serial in, parallel out shift register, parallel in, serial out shift register, parallel in, parallel out shift register, bidirectional shift register, universal shift register. So the serial in to serial out shift register is loaded with serial data, one bit at a time, with stored the data being available at the output in parallel form. Serial in, serial out is SISO. The data is shifted serially in and out of the resistor one bit at a time in either to left shift or the right shift under the clock control. Parallel in, parallel out, parallel out means the parallel data is loaded simultaneously into the resistor and transferred to the respective outputs by the same clock pulse. Parallel serial out is loaded, the parallel data is loaded into the resistor simultaneously and is shifted out the resistor serially one bit at a time under the same clock pulse. Now let us see one by one. Serial in, serial out shift register. So the shift register which allows serial input and produces serial output is known as a serial in, serial out shift register. There is only one output. The data leaves the shift register one bit at a time in a serial pattern. The name is called as a serial in, serial out shift register. So let us consider the example. Let us consider the input is a 111. Initially all the flip flop is reset condition. So the there are 4 flip flops. The input is a 4 binary number. So therefore the 4 flip flops are needed. So all the flip flops are initially reset condition. So the Q3, Q2, Q1, Q0 is 0. If the entry of the 4 bit binary number 111 is made to the resistor, this number should be applied to D in bit with the LSB bit. So the D input of third F of 3 flip flop is that is D3 is connected to the serial data input D in. The output of the F of 3 is connected to the input of the next flip flop D2, and the output of the flip flop D2 is connected to the input of the flip flop D1, and the output of the D1 flip flop is connected to the next flip flop is D0 and so on. So this is the logic diagram of serial in, serial out shift register. So the serial input is applied to the F of 3 flip flop. The output of the F of 3 flip flop is connected to the flip flop input of the flip flop 2. the output of the flip flop 2 is connected to the input of the flip flop 1, and the flip flop is the output of the flip flop 1 is connected to the input of the first flip flop 0. Or likewise, or if it takes us f of 3, f of 2, f of 1, f of f1, f of 2, f of 3, f of 4, and increasing manner. So, let us see the now we discuss the operation. So, before apply of the clock signal, initially all the flip flops are initial. So, Q1, Q3, Q2, Q1, Q0 is 0, 0, 0, and apply the LSB bit of the LSB bit D in. So, D in is 1, the first bit is 1. Now, apply the clock, the first falling edge of the clock, the f of 3 is set, and store the resistor at the output in the register f of 3 is Q3 equal to 1, and the remaining output is 0, 0, 0. So, therefore, the output is what's output? Output is 0. Next, apply the next input is D1 is 1, D1 is 1, and now apply the clock. The next negative edge of the clock pulse f of 2 will set and store the data is Q2 is 1, is also is a Q3 1 and Q2 1, remaining Q1 Q2 is a 0. So, the output of the first flip flop is shifted to the next flip flop. So, the output is Q2 1, the input is 1, the input is when the clock is applied, the input is applied to the f of 3. So, the output of the f of 3 is 1. Therefore, the serial output is 0. Next, apply the next bit. Next bit is D in is 1. Now, apply the clock pulse. So, the third clock edges bits is f of 1 will be set. The output will be modified into Q3, Q2, Q1 is 1, 1, 0. So, that is the next bit is 1 is applied to the f of 3. So, already the output is Q1 is Q3 is 1. Now, when the apply the clock pulse, the Q3 output is shifted to the f of 2. The output of the f of 2 is shifted to the f of 1. The output of the f of 1 is shifted to the f of 0. So, finally the flip flop output is 1, 1, 1, 0. The serial output is 0. Next, similarly, D in is 1. The D in 1 is applied to the f of 3. Now, apply the clock signal. The flip flop output is already the flip flop output is shifted to the flip flop 2. The output of flip flop 2 is shifted to the flip flop 1. The output of flip flop is shifted to the flip flop 0 is by the clock pulse. So, this is a truth table of SISO. So, initially all the flip flop is 0, 0. So, when the input to 1 is 1 and apply the clock signal, the output of the flip flop is shifted to the next, and the next output is shifted to the next flip flop, the output of the is shifted to the next flip flop, and so on. So, finally the serial data, the direction of the serial data is the output is 0, 0, 0, 0, 0, and the fourth clock pulse the output is 1, 7th clock is output is 1, 8th clock is output is 1, 9th clock is output is 1. Next, serial in parallel shift register. The shift register which allows serial input and produce the parallel output is known as serial in parallel shift register. This is a 4-bit SIPO register. This is an example of 4-bit SIPO register. So, here input is a serial, the only one input is, but the output is a 4. Next, parallel serial out. So, the parallel serial out means the input is applied the parallel and the produce the serial output is so known as serial in parallel serial out shift register. So, this is a logic diagram of the parallel serial out shift register. Next, parallel shift register. Here the input is applied the parallel simultaneously and also produces the output as also simultaneously. So, it is known as a parallel shift register. So, consists of 4 D flip flop which connected the clear signal and clock signals are connected to the all 4 flip flops. So, there are no interconnection between the individual flip flops. So, no serial shifting of the data is required. The data is given as input separately for each flip flop, and the same way the output is collected individually from each flip flop. So, the logic diagram of parallel shift register. Universal shift register. Universal shift register is a type of register that contains the both right shift and the left shift. It has also parallel load capabilities. So, generally this type of registers are taken as memory elements in the computers, but the problem with this type of register is that shifts only in the one direction. So, the shift register is a combination of bidirectional shift register and the unidirectional shift register. So, a shift register which can shift the data in only one direction is called as a unidirectional shift register. When the shift register is which can shift the data in both directions is called as a bidirectional shift register. So, applying the same logic, the shift register which can shift the data in both direction as well as load it parallelly is known as a universal shift register. So, the shift register is capable of performing the following operation: parallel loading, left shifting, right shifting. So, the control input is connected to the logic 1 for parallel loading operation, whereas it is connected to 0 for serial shifting. The mode control input is connected to the logic 1 for parallel loading, when the mode control input is connected to 0 for serial shifting. When the mode control pin connected to the ground, the universal shift register acts as a bidirectional resistor. A serial left operation, the input is supplied to the serial input which goes to the AND gate 1, whereas when the shift right operation means serial input is applied to the D input. So, this is a block diagram of the logic diagram of universal logic circuit. This is a block diagram of universal shift register. Thank you.